Activity 3. Take a few zinc granules in a conical flask. Add about 5 ml of dilute hydrochloric acid to the conical flask. Observe the change in flask. What changes do you notice? Now, keep a burning matchstick near the mouth of the conical flask. What happens to the burning matchstick? Touch the test tube with your fingers. What do you notice? Is there any change in temperature? The actual equation is Zn solid pieces, zinc granules plus 2HCl hydrochloric solution gives rise to ZnCl2 zinc chloride plus H2 hydrogen gas. Slowly, the zinc pieces start dissolving in hydrochloric acid to produce heat. When we bring burning matchstick near to the mouth of conical flask, it puts off immediately, which tells us that hydrogen gas is liberated, which has the property to put off the fire. Later on, if we touch the test tube, it will be hot, which represents that there is a change in temperature. Chemical equation. In activity 1, when calcium oxide reacts with water, a new substance is formed which is unlike either calcium oxide or water. This description of chemical reactions takes a long time to write or read, so it can be written in a shorter form as a word equation. Calcium oxide plus water gives rise to calcium hydroxide. So that we can describe a chemical reaction by using least possible words or symbols, which is called a chemical equation. Or the chemical equation is a statement that describes a chemical change in terms of symbols and formulae. Before we start interpreting the meaning of chemical equation, let us know a few terms used in writing a chemical equation. A. Reactants. The substances which take part in a chemical reaction are called reactants. The reactants are always written on the left hand side of a chemical equation. Example: Zn plus 2HCl gives rise to ZnCl2 plus H2. Here, in this equation, Zn zinc, hydrochloric acid, HCl are reactants. B. Products. The substances formed as a result of chemical change are called products. The products are always written on the right hand side of a chemical equation. In the above example, ZnCl2, zinc chloride and H2 hydrogen are the products. 2. A chemical equation consists of formulae or reactants connected by a plus sign, an arrow followed by the formula of products connected by a plus sign. 3. The sign of arrow is read to yield or gives rise to. Examples: 2Mg plus O2 gives rise to 2MgO magnesium oxide. Here, Mg and O2 are called reactants. MgO is called a product. 2. CaO plus H2O gives rise to CaOH twice plus heat. CaO and H2O are the reactants and CaOH twice is the product. Here, number of atoms of oxygen element at left side reactant of equation is equal to the right hand side product of chemical equation is called a balanced equation. NaNO3 gives rise to NaNO2 plus O2 is called unbalanced equation because oxygen atoms on the reactant side is 3, whereas on the product side is 4. 2NaNO3 gives rise to 2NaNO3 plus O2 is a balanced equation. Na2SO4 plus BaCl2 gives rise to BaSO4 plus NaCl, unbalanced equation because sodium atoms on the reactant side is 2, whereas on the right side is 1. Similarly, chlorine atoms on the reactant side is 2, whereas on the right side is 1. Do the atoms of each element in left side are equal to atoms of their corresponding element? Are the atoms of all elements of reactants present in the products? Is there any element that is taking part in the reaction disappear? Writing chemical equations. Can you write a chemical reaction in any other shorter way other than the way discussed above? Chemical equations can be made more precise and useful if we use chemical formulae instead of words. Generally, a compound is written by giving its chemical formula in order of symbols, which tells us about the symbols of the constituent elements, and the subscript written indicate the number of atoms of each element present in the compound. If no subscript is written, we assume that the number as 1. Example, Mg plus O2 gives rise to 2MgO. Here atoms of magnesium is assumed is 1. Similarly, zinc plus HCl gives rise to ZnCl2 plus H2. Here, zinc, Zn number of atoms are 1. In HCl, number of atoms are 1. But above equation, number of atoms of elements in left hand is not equal to the number of atoms of elements reactants in the right hand side. The products is called unbalanced chemical equation. Balancing chemical equations. According to the law of conservation of mass, the total mass of the substance that are taking part in chemical reaction must be the same before and after the reaction. You know, an atom is the smallest particle of an element that takes part in a chemical reaction, as it is the atom which account for the mass of any substance. The number of atoms of each element before and after the reaction must be the same. All the chemical equations must balance because atoms are neither created nor destroyed in chemical reactions. A chemical equation in which the number of atoms of different elements on the reactant side, left side, are same as those on product side, the right side, is called a balanced reaction. Following knowledge is necessary before one starts writing a balanced equation. 1. Whether or not the reaction takes place between two or more reactants. 2. One must know all the products formed during the chemical equation. 3. One must know the correct symbols and formula of the reactants and products.